Hello and welcome, future pharmacists. If you're a B-Pharm student, especially in your third semester, you are in the perfect place. Today, we're going to break down a really fundamental piece of equipment in pharmaceutical manufacturing, the horizontal tube evaporator. So let's get right into it. Okay, so just imagine this for a second. You've got this amazing, potent herbal extract, but it's super diluted, just swimming in water. Now, to turn that into an actual medicine, you have to get rid of most of that water, but you can't destroy the active ingredient in the process. I mean, that's a huge challenge in drug manufacturing, and it's the exact problem the horizontal tube evaporator was built to solve. All right, before we dive into all the nuts and bolts and pipes, let's start with the basic science that makes this whole thing possible, and that's the principle of heat. So, at its heart, this evaporator runs on a really simple, universal law of physics: heat transfer. Heat always flows from something hot to something cold. You can kind of think of it like a giant industrial-sized kettle. You've got your heat source, which in this case is steam, and you've got the liquid you want to boil. The evaporator is just a really efficient way of getting the heat from that steam into your liquid. And you can see that journey broken down right here. First, hot steam gets pumped into a series of tubes. Then that heat conducts right through the metal walls of the tubes, like how a spoon gets hot when you leave it in a cup of tea. Finally, the liquid that's all around those tubes soaks up that heat, starts to boil, and evaporates. It's really just a simple, elegant, three-step chain reaction. Okay, so we've got the why. Now let's look at the what. Understanding the construction, the anatomy of this machine is so important, because once you understand the parts, the whole process just clicks. First thing you'll notice is the main body. It's this big cylindrical tank. But the real action, the magic, happens inside. It's packed with a whole bundle of tubes, and they're all arranged horizontally. That specific layout is exactly what gives the horizontal tube evaporator its name, and it's totally key to how it functions.
Now, this is a super important point. The space inside all of those horizontal tubes, that's called the steam chest, or sometimes the calandria. You can think of this as the engine of the whole operation. Hot steam gets pushed in one side, it fills up all the tubes, transfers its heat, and as it cools down and condenses back into water, it just flows out the other side.
So if the steam is inside the tubes, what about the liquid we're actually trying to concentrate? Well, that's here, in what we call the liquid chamber. It's the whole space outside and all around that bundle of hot tubes. This design is brilliant because it maximizes the surface area, the contact between the hot tubes and the liquid, which makes the whole thing work way more effectively. And of course, you've got the plumbing, all the little pathways to manage the flow of everything. There are 4 main connections you need to know: an inlet for your diluted feed liquid, a steam inlet to get things hot, an outlet at the top for the vapor to escape, and finally a product outlet at the bottom to collect all that concentrated good stuff. Okay, we've covered the principle and we've covered the parts. So now let's put it all together and see how they work in the complete cycle. This is where we see the machine in action. Let's walk through the whole process. First, your feed solution is pumped into the shell, where it completely surrounds the tubes. At the exact same time, hot steam is being fed inside those tubes. That steam transfers what's called its latent heat to the liquid, which causes it to boil and turn into vapor. That vapor, being lighter, rises to the top where it's piped out through an outlet, usually to be condensed back into water somewhere else. So what's left behind? Your valuable concentrated liquid, which is just drained right from the bottom. It's as simple as that. So we know how it works, but why should you care? Why does this specific piece of equipment matter in your career? What's it actually used for? And maybe more importantly, what are its strengths and weaknesses? This is the practical stuff you really need to know. Out in the real world, you're going to see this evaporator used for all kinds of things, like concentrating licorice extract or senna infusions, classic pharmacognosy products. It's also an absolute workhorse for making industrial syrups and in bulk drug manufacturing, where the main goal is just to get rid of a ton of water as efficiently as possible. Look, no piece of equipment is perfect, right? And a good pharmacist knows the pros and the cons of every tool in their toolkit. The horizontal tube evaporator is a fantastic example of a machine with some very clear trade-offs. So on the plus side, its design is really simple, which makes it easy to operate and pretty cheap to buy. It's also compact, so it doesn't eat up a lot of precious factory floor space. But on the downside, its heat transfer isn't the best. It's not the most efficient out there. It really struggles with thick, syrupy liquids because they don't circulate well around the tubes. And this is a big one. Because the liquid sits in there getting heated for a while, it's not great for heat-sensitive drugs that could break down. And finally, those tubes can get gunked up with scale over time, which hurts its efficiency even more. So, if you're going to remember one thing, remember this: the horizontal tube evaporator is a reliable, cost-effective workhorse. It is fantastic for simple jobs where you have thin, watery solutions that aren't sensitive to heat. But the moment you're dealing with something delicate or thick, you have to be really aware of its limitations. And that kind of leads us to a final thought here. We've just established that this evaporator's biggest weakness is that long heating time, which is a real problem for sensitive drugs. So that begs the question, doesn't it? If you had a really valuable, heat-sensitive compound you needed to concentrate, what kind of evaporator would you use instead? That's a great question to keep in the back of your mind as you continue with your studies.